This is the third review tape in our elementary algebra series. In this review tape, we'll be going over examples dealing with addition, subtraction, multiplication, and division of polynomials, and factoring. But this is just a review. If you find that any of the examples confuse you and you're not able to follow them, then we suggest that you go back to the original videotape lessons dealing with these topics. Okay? This is like a final review after you've already mastered the material. Okay, let's start with the idea of a polynomial. And in the first problem, given the polynomial minus 5x cubed plus 4x squared minus x plus 3, I want you to answer a few questions. First question, how many terms are there? Second question, what is the coefficient of each term? Third question, what is the degree of each term? And finally, what is the degree of the polynomial? Okay, let's go back to the first question. How many terms are there? Well, basically, a polynomial is a sum of terms. And we can think of a term as an expression which can be written as a product of constants and or variables. So in this case, we see that we have 4 terms which are being added together. The first term is minus 5x cubed. In other words, it's minus 5 times x times x times x. It is a product of constants and variables. And to that term, we add the next term, which is plus 4 times x, 4x squared. Then we add the third term, which is minus 1 times x, and the fourth term, which is just the constant. So a term is an expression which can be written as a product of constants and or variables, and here we have sum of 4 terms. Okay? So how many terms are there? 4. What is the coefficient of each term? Okay, the coefficient of the term is the constant part of the term. It's the numerical coefficient of the term. And it always has the sign associated with it. Remember, we're talking about a polynomial as a sum of terms, so the term has the plus or minus sign as part of the coefficient. So the coefficient of the first term is minus 5. Of the second term, we have a plus 4. The third term, the coefficient is minus 1. And the fourth term, it's just a constant term. The coefficient is 3. There is no variable part on the fourth term. What is the degree of each term? Okay, the degree of a term in a polynomial is the power of the variable present in that term. So in the first term, the degree is 3. In the second term, the degree is 2. In the third term here, the power of the variable there is 1. The constant term, we speak of the constant term as having degree 0. Okay, just take that as a definition. The constant term has degree 0. So the degrees are 3, 2, 1, and 0. Finally, what is the degree of the polynomial? The degree of the polynomial is the degree of the term of highest degree. Okay, so in this case, the degree of the polynomial is 3. This is the term of highest degree. The degree of the polynomial is 3. Okay, now we'd like to work on simplifying some algebraic expressions dealing with polynomials, combining and simplifying. Let's look at the second example here. Combine the following. 5x squared minus 3x plus 6 minus 3 times, in parentheses, 2x squared minus x plus 5. Okay, so what we have here is this polynomial, and we're going to subtract 3 times this polynomial from it. Okay, now what we can do, obviously the distributive law is called for here. We can distribute the 3 and then subtract this polynomial from this one, or we can think of this as adding a minus 3 times this and actually distribute the minus 3, which works a little easier, I think. So let's do that. 5x squared minus 3x plus 6. Now let us distribute the minus 3 through the through the parentheses here. Minus 3 times 2x squared, that's minus 6x squared. Minus 3 times minus 1x, that's plus 3x. And minus 3 times plus 5, or minus 15. Then we don't have to worry about the subtraction. Everything is taken care of. Now we would like to simplify. We're going to be combining the like terms. Well, we have a 5x squared and a minus 6x squared. These are like terms. They have the same variable part. And we combine the numerical coefficients of the terms. 5x squared minus 6x squared, that's minus 1x squared. Then we have a minus 3x and a plus 3x, giving us 0x, and that drops out. And then finally the constants, plus 6 and minus 15 for a minus 9, giving us a final answer of minus x squared minus 9. Our third example, we would like to combine and simplify the following. 4xy times x squared minus 3y in parentheses minus 2x squared times xy plus y in parentheses, and then minus, in parentheses, x squared y minus 5xy squared. Okay, we're going to use the distributive law 3 times here. First, we will distribute the 4xy through the first parentheses. 4xy times x squared, giving us 4x cubed y. Okay, all together, we will have x 3 times here. 4xy times x for 4x cubed y. Now, 4xy times minus 3y. 4 times the minus 3 gives you the minus 12. xy squared. Okay, we've taken care of the first parentheses. Now let's move over here. Once again, we can think of this as a plus a minus 2x squared and distribute the minus 2x squared through the parentheses. Minus 2x squared times xy, giving us minus 2x cubed y. And then minus 2x squared times plus y, minus 2x squared y. And then finally, we can think of this as, say, a minus 1 to be distributed through the parentheses. Minus 1 times x squared y is minus x squared y. Minus 1 times minus 5xy squared for plus 5xy squared. Now let us combine the like terms to simplify this. Let's see, we have a 4x cubed y and a minus 2x cubed y. Those are like terms, and they combine to give us 2x cubed y. Then we have a minus 12 xy squared and a plus 5xy squared. They combine to give us a minus 7xy squared. And the last pair, we have the minus 2x squared y and the minus x squared y combining for minus 3x squared y. And there we have the answer. In the next problem, problem 4, I want you to multiply and simplify the following. x minus 3 times, in parentheses, x squared plus 3x minus 4 plus the product x plus 5 times x minus 2. I want to multiply two polynomials here, the same thing over there, and then add the resulting polynomials. Okay, now there is a tape going over multiplication of polynomials. What we're going to do here is basically use the distributive law repeatedly. Think of this as, say, x minus 3 times something. We can make it x times of something and then minus 3 times of something. So we'll make this x times x squared plus 3x minus 4, and then the minus 3 times x squared plus 3x minus 4, plus this product, which we will take care of separately. Now we will again use the distributive law here. X distributed through the parentheses here gives us x times x squared, x cubed, x times 3x for 3x squared, x times minus 4 for minus 4x. And now we will distribute the minus 3 through the second parentheses. Minus 3x squared, minus 3 times 3x is minus 9x, minus 3 times minus 4 for plus 12. Now we could have done the same thing on the second product over here. We could have said it's x times the x minus 2 and then the 5 times the x minus 2. But because it is a special case, that is, a binomial times a binomial, two terms times two terms, we can also handle this product by using the FOIL method. That is, first multiply the first terms, then the outer terms, the inner terms, and the last terms. It's the same thing you'd get if you use the distributive law twice. Okay, so let's see what we have. The first terms, x times x, that's x squared. The outer terms giving us minus 2 times x, and the inner terms plus 5 times x. Well, the minus 2x and the plus 5x combine to give us plus 3x. And the last terms, finally, 5 times minus 2 for a minus 10. Okay, very often when we multiply binomials, the outer and the inner terms can combine like this. First, the outer and inner combining to the plus 3x, and then the last minus 10. Now let us see what we can do in the way of simplifying the whole thing. X cubed, well, this is the only term involving an x cubed. Let's see, for 3x squared, for x squared, we have a 3x squared, a minus 3x squared, and a plus x squared. 3x squared and minus 3x squared, that's 0x squared plus 1x squared, giving us 1x squared. Now we have a minus 4x, a minus 9x, and a plus 3x. Minus 4x and minus 9x combine to minus 13x, plus 3x combining to minus 10x. And last, the constant terms, the plus 12 and the minus 10 combining to the plus 2. For a final answer, x cubed plus x squared minus 10x plus 2. Okay, in our fifth problem, I also want to multiply and simplify the following. 2x plus 5 quantity squared, take away in parentheses x minus 4 squared. All right. Now, we must not forget our order of operations that we've studied earlier. Here we're going to square 2x plus 5, multiply 2x plus 5 times itself. Here we're going to square x minus 4, multiply x minus 4 times itself, and then, after we finish with this multiplication, we will then subtract this from that. Okay, do not start by saying, well, this is like a minus 1, and I'm going to distribute it through the parentheses. Order of operations prevails, and this power, which is a type of multiplication, is going to occur before this subtraction. Okay, so it's 2x plus 5 times 2x plus 5, then subtract the product, x minus 4 times x, 2x plus 5 times 2x plus 5, then take away this product here, x minus 4 times x minus 4. Okay, and we will do the multiplication using FOIL in each instance. But at the end, remember that we will have the minus sign. We have to do the subtraction separately. OK, so here, first giving us 2x times 2x, 4x squared. The outer term is plus 10x, and the inner term is plus 10x, so plus 20x, and the last term's plus 25. And then similarly on the second pair of parentheses, first, x squared. Outer is minus 4x, and the inner is minus 4x. That's minus 8x. The last is plus 16. At this point, we can now think of the subtraction as distributing a minus 1 through the parentheses. So we get 4x squared plus 20x plus 25. Now distributing the minus 1, minus 1x squared, minus 1 times minus 8x, that's plus 8x, minus 1 times plus 16, minus 16. We get plus 4x squared, and minus 1x squared, that's plus 3x squared, plus 20x, and plus 8x, that's plus 28x, and the constants plus 25 and a minus 16 for a plus 9. And here we have our answer. In the next example, we're going to use long division to find the quotient that's indicated. Uh, 2x cubed minus 5x squared plus 3x minus 1 divided by x minus 2. This means this polynomial divided by this polynomial, and we're actually going to use long division to find this quotient. 2x cubed minus 5x squared plus 3x minus 1 over x minus 2. Now, when using long division, the first thing to make sure is that the polynomial that we're going to be dividing into, this polynomial here, should be arranged in according to the degree of the terms. The terms should be ordered. It should be arranged in descending order of degree. Okay, third degree term, second degree, first degree, 0 degree term. Furthermore, if any of the terms were missing, I would want to put placeholders in. This example we have third, second, first, and 0 degree. In the next example, I'll show you what I mean by adding in the missing terms. Okay, x minus 2 to be divided into a polynomial which has been arranged according to descending order of the degrees of the term. First thing to do is to look at x and 2x cubed. How many times does x go into 2x cubed? Okay, we would say 2x squared times. And then we perform the actual multiplication, whereas we have to distribute the 2x squared times the x minus 2. The 2x squared times x gives us the 2x cubed. The 2x squared times the minus 2 gives us minus 4x squared. And just as in arithmetic, we would now subtract, bring down the next term, and continue our process. Okay, now when we subtract, be careful. Subtract means we will be changing the signs of these terms and adding. Okay, so 2x cubed, take away 2x cubed, that drops out. Minus 4x squared, take away, minus 5x squared, take away a minus 4x squared is minus 5x squared plus a 4x squared, giving us minus x squared. And bring down the next term, the plus 3x. If you would prefer, of course, you can actually go through the business of saying, I will cancel out this term, write the sign, change the signs to the opposite, and add. Or you can do it in your head. OK, how many times does x go into minus x squared? Minus x times x gives us minus x squared. But don't forget, we also have to multiply the minus x times the minus 2 for plus 2x. We will now subtract. So we change the signs and add. OK, the x squareds, of course, drop out. The plus 3x and the minus 2x gives us plus 1x, and we bring down the next term. How many times does x go into x? Of course, just once. We multiply 1 times x minus 2, giving us x minus 2. We subtract, which means we change the signs and add. Minus 1 and the plus 2 gives us a remainder here of plus 1. This is the remainder. So we have this plus that remainder. Okay, let's do another long division, a slightly more complicated one now. Use long division to find the quotient. And here I want x to the 4th minus 10x squared plus x plus 12 divided by x plus 3. Okay, now x plus 3 into this. Now, this polynomial should be arranged in, the term should be arranged according to descending order, the degree, and I want to make sure we have all the degrees taken care of. This is 4th degree, 2nd degree, 1st degree, 0th degree. We're missing the 3rd degree term, so we would leave space for it. Either actually leave the space or put in a term like this, 0x cubed minus 10x squared plus x plus 12. I think it's convenient if you actually put in the 3rd degree term with a coefficient of 0, 0x cubed. Now we go through the same long division process that we did before. X into x to the 4th goes x cubed times x, that's x to the 4th. X cubed times 3, that's 3x cubed. Subtract, changing the signs, and adding, we wind up with minus 3x cubed. Bring down the next term, minus 10x squared. X into minus 3x cubed goes minus 3x squared times. Minus 3x squared times x gives us, of course, the minus 3x cubed. Minus 3x squared times 3, minus 9x squared. Changing the signs and adding, we get minus 10x squared plus 9x squared minus x squared plus x. Bringing down the next term. How many times does x go into minus x squared? Well, minus x times. Minus x times x is minus x squared. Minus x times plus 3 minus 3x. Changing the signs, in this case, plus and adding, gives us 4x. Bring down the next term. And now, how many times does x go into 4x? 4 times. 4 times x gives us 4x. 4 times is 3. That's plus 12. Subtracting, we get 0. Change the signs and add. Everything drops out. So this is our quotient, and the remainder is 0. Now we have been multiplying out polynomials. Let's now try to work the other way and go over factoring of polynomials and algebraic expressions. I want to factor each of the following as completely as possible. And problem 8, we will have 6x squared y minus 12x cubed y squared. In factoring, the first thing to do is to look for the greatest common factor, okay, that we could pull out in front of these terms. Okay, and let's first take care of the constants. We have a 6 here and a 12 here. The greatest common factor would be a 6 for the constants. Now, for the x terms, we have an x, the x squared and an x cubed, the most we could pull out would be an x squared. And from the y and the y squared, the most we could pull out is a y. We now see what is left in each of these terms. Okay, from 6x squared y, we have taken everything out. In other words, 6x squared y times 1 would give us that. Now let's look to go from this term to that. To go from 6x squared y to minus 12x cubed y squared, we'd have to multiply by the minus 2 to get the minus 12, an x and a y. Now let's check our factoring by the distributive law. 6x squared y times 1, and then the 6x squared y times the minus 2xy, giving us minus 12x cubed y squared. Okay, 2x squared plus 6x. Okay, once again, the proper way to start any factoring problem is always to see if there is some factor, some common factor that you can pull out from all the terms. And in this case, once again, we see that we can pull out from the 2 and the 6 a 2, and from the x squared and the x an x, leaving us in the first term with an x, and in the second term with a 3. Multiplying it out, 2x times x, 2x squared, plus 2x times 3, 6x. X squared minus 8x plus 12. Now, once again, we start by looking for the common factor. And we notice in this example, there is no common factor for these three, no common factor other than 1 for these 3 terms. Okay, at this point, we say, well, it's a trinomial, and we have certain techniques for factoring trinomials, and possibly we can write it in this kind of form. But the first thing you should always say when starting a factoring problem, is there some common factor that I can pull out? Going back here to problem number 9, you wouldn't want to start this by saying, in other words, I am going to try to factor this the way I factor second degree expressions. I am going to first look for the common factor. Since this one had it, that was the way to go. This one, however, does not have the common factor. So then we look at some other technique, and we try to say, use that FOIL method, but in reverse. Try to figure out what 2 binomials multiplied together might give us this trinomial. Okay, well, it's clear that if we had an x here and an x here, the first terms would give us the x squared. Now, we're going to put some 2 numbers in here. Okay, now two numbers which multiply to plus 12 and which add to minus 8. Now, if they're going to multiply to plus 12, they're either both positive or they're both negative, because their product is going to be positive. So either 2 positives or 2 negatives. But since they have to add to minus 8, then I know they both have to be negative. 2 numbers which multiply to plus 12 and add to minus 8. And if you think about that for a little while, I'm sure you'll come up with the minus 6 and the minus 2, adding to the minus 8 and multiplying to the plus 12. And checking this factoring by FOIL, x squared minus 2x minus 6x for the minus 8x and the plus 12. Okay, problem 11. X squared minus 10x minus 24. Once again, the first thing to do is to look for a common factor. And since we do not find one, then we proceed to this technique. Now, we are looking for 2 numbers which multiply to minus 24 and add to minus 10. By the way, this business only is valid when the lead coefficient happens to be a plus 1. Okay, we are looking for 2 numbers which multiply to minus 24 and add to minus 10. Now, unlike over here, here they had to multiply to plus 12. So they either were both positive or both negative. Here they're multiplying to a negative, which means one will be positive and one will be negative. And they're going to add to a minus 10. Well, if one is positive and one is negative, how do you add numbers with different signs? You basically block out the signs and sort of subtract. So we're basically looking for sort of 2 numbers which multiply to the minus 24. Okay, but if you were just to consider their absolute values, their difference would give us this 10. It's basically a subtraction problem rather than an addition problem. Okay, so if you're thinking in terms of, well, 4 and 6, they multiply to 24 and they add to 10, that's not the way to go because they have to have opposite signs. And if you think about it a little bit, I'm sure you will come up with the minus 12 and plus 2. They multiply to minus 24 and they add to minus 10. Let's check it by FOIL. X squared plus 2x minus 12x for the minus 10x minus 24. And just, I might mention that if it had been x squared minus 10x plus 24, then you would have gotten the x minus 4 times the x minus 6. This would have given you x squared minus 10x plus 24. In other words, to get the plus 24, they'd have the same sign. And then you'd have your traditional type of addition. Okay, but because it was the minus 24, okay, the 10 was the difference between 12 and 2. Problem number 12. 4x squared plus 28x plus 40. As always, the first thing to do is to ask yourself, is there any common factor that I can pull out? And in this case, there is. You can pull out a 4, leaving you with x squared plus 7x plus 10. Now, it did say factor each of the following as completely as possible. And here we have a trinomial, which we can factor into two binomials. Notice here, of course, there are no more common factors. So we're looking for two numbers which multiply to plus 10 and add to plus 7, and that's simple enough, plus 2 and plus 5. This gives us x squared plus 5x plus 2x for the plus 7x, and then the plus 10. OK, continuing with our factoring, let's try this 3x squared minus 2x minus 8. Okay, now this is a slightly more complicated problem. First, we look for a common factor, and we don't have any other than 1. So we try something else. We would like to write this as the product of two binomials if we could. What makes this problem more complicated than all the other ones we've considered so far is the lead coefficient is not 1. The last example, the lead coefficient wasn't 1, but we were able to factor out the 4. So in all of the ones, in all the trinomials we've factored so far, the lead coefficient was a 1. And we were able to say, well, this had to be a 1x and a 1x and figure out just the other two spots. But here, when it's not a 1, then there are, say, different ways that we could get the 3x squared. We could have a plus x here and a plus 3x here, or the other way around, a 3x here and x here. So we have to sort of consider twice as many possibilities. And in the videotape where I actually go over the methods for factoring, we do this in much more detail. I just want to do this problem fairly simply. We write down the possible factors of this coefficient, say on this side of the line, and the possible factors of 8, integer factors. Ignore the sign for the moment. Okay, the integer factors of 8, let's see, we could have 8 and 1 and 4 and 2. And on one side, you have to consider both possibilities. So if we say just a 3 and the 1, let's also consider here 1, 8, and 2 and 4. On one side, we're going to consider them both ways. What I'm doing here basically is saying I'm going to say put a 3x here and an x here. That's the 3 and the 1. And I'm trying to figure out what coefficient, what number should go in there. Now, where does this minus sign come into play? The minus sign comes into play telling me that the numbers that go in here are going to multiply to a negative. Therefore, they're going to have opposite signs. Basically, in that case, I consider this a type of subtraction table. And here's what I'm going to do. I'm going to multiply the 3 times the 1 and the 8 times the 1. This gives me a 3. This gives me an 8. The difference is a 5. And I'm going to be looking for a difference of 2. Don't worry about the plus or the minus sign. We can take care of that later. Basically, I want to get a difference, a subtraction, a difference of 2. 3, 8, the difference is 5. OK. Now we try the 3 with the 2 and the 1 with the 4. 6 and 4. In other words, 3 times 2, that's 6. 1 times 4, that's 4. 6 take away 4, that gives me the 2. Okay, for this to work, the 3 is to multiply a 2. The 1 for the 1x is to multiply the 4. So that tells me how to position them. Now we worry about the signs. We know either it's going to be a plus and a minus or a minus and a plus. And we want to make sure that the outer and inner together give us the minus 2x. So we'll put the minus here and the plus here. So we'll have minus 6x and the plus 4x for the minus 2x. And now the whole thing works out. 3x squared minus 6x plus 4x minus 2x minus 8. Okay, in the next example, also to factor as far as possible, 12x cubed plus 34x squared plus 20x. First thing, of course, to look for is some kind of common factor, and the greatest common factor that we can pull out in this case is a 2x. When we pull the 2x out, we are left in the first term with a 6x squared, and then a 17x, and then a 10. So basically, we'd like to discuss factoring 6x squared plus 17x plus 10. And we're going to do the same kind of thing we did over in the last example. We're going to consider the different ways to make 6 integer factors of 6. Well, let's say 6 and 1 and 3 and 2. And the different ways to make 10. So 10 and 1 and 5 and 2. And we're going to reverse each of these. So 1 and 10 and 2 and 5. Now, because this is a plus 10, these two numbers that go in here are going to have the same sign. Therefore, it's going to be basically an addition table. Either both be positive or both be negative, but the effect will be that we'll be adding on our table. Remember, in the last example, we had a minus 8. In other words, the chart is made the same way. The different ways to make 3, the different ways to make 8. The minus tells me it's a subtraction table. Here, it's the ways to make 6, the ways to make 10. This plus tells me it's an addition table. And the same kind of crisscross multiplication, this time looking for a sum of 17. OK, 3 times 1, that's 3. 2 times 10, 20. 3 plus 20, 23. That's no good. OK, now, 3 times 2 and 2 times 5, 6 and 10, 16. That's not right. 30 and 2, no good. 15 and 4, that's also no good. So we can knock out the 3-2 combination. We now try the 6-1 combination. 6 times the 1, that's 6, and 10, 16. That doesn't work. But now we have it. 6 times 2, that's 12. 5 times 1. 6 times 2 for 12. 1 times 5, 5. 12 plus 5, 17. So on the x side, we'll have the 6x and the 1x. Now, the 6 is to multiply the 2. Since the 6 is on the outside, the 2 is going to have to be on the outside. You know, the way FOIL works. The 5 is to multiply the 1. And let's see, we have 6x squared. We want a plus 12x and a plus 5x for the plus 17x, and then the plus 10 at the end. Either they were going to be both positive or both negative, and since this was plus, obviously they're both positives. So 2x times 6x plus 5 times x plus 2. And then we factored this completely. You can think of this, by the way, there is no common factor to pull out, and you can think of this as our typical trinomial, if you'd like. In other words, looking for two numbers which multiply to minus 25 and add to 0, and of course they're plus 5 and minus 5. Checking by FOIL, we get x squared minus 5x plus 5x for 0x and minus 25. However, most people skip this intermediate step and say, well, look, this is simply the difference of two squares. If you have something like a squared minus b squared, we know we can write this as a plus b times a minus b, and we get this directly. If we have the difference of two squares, this is the more direct method of getting it. Okay, problem number 16. 12x to the fourth minus 27x squared. First thing to do is to look for any common factors. From the 12 and the 27, we can pull out a 3. From the x to the fourth and the x squared, we can pull out an x squared, leaving us with, in the first term, 4x squared, and then minus 9. Now, we are not finished at this point. This factorization is not complete. It said factor as far as possible. We notice that 4x squared minus 9 is itself the difference of two squares. So this can be written, think of this as a squared minus b squared. We can write this as a plus b times a minus b. And now we have taken it as far as it goes. And the last example on this videotape, reduce the following fraction to lowest terms by eliminating the common factors from the numerator and the denominator. X cubed y minus x squared y squared all over x squared minus xy. So we would like to factor completely the top and the bottom, and then look to see if we can cancel any factors, and doing that, reduce this to the lowest term. So let's work with the numerator and denominator separately. In the numerator, okay, common factors in the numerator, we notice that we can pull out, from the x cubed and the x squared, we can pull out an x squared. From the y and the y squared, we can pull out a y, leaving us with upstairs x minus y. Checking that, we have x cubed y minus x squared y squared. Similarly, downstairs, from the x squared and the x, we can pull out an x. And from 1 and y, there's nothing we can pull out. So let's see what we're left with. X into x squared, x times. And here we're left with the minus y. X squared minus xy, multiplying it out. We now notice that both the numerator and the denominator have a factor of x minus y, which we can cancel out. Furthermore, the numerator, which is x times y, also has a factor of x, which can cancel the x downstairs, leaving us with a final answer of xy. And that brings us to the end of this tape.